what's going on, guys? Let's look at this problem right here. Here's question is asking, design an NMOS differential pair for a voltage gain of 5 and a power budget of 2 milliwatts, subject to the condition that the stage following the differential pair requires an input CM level of at least 1.6 voltage. Assume μnCox is equal to 100 microampere per volt square, lambda is equal to 0, and VDD is equal to 1.8 voltage. Okay, now from the power budget and supply voltage we have ISS, that is equivalent to 1.1 milliampere, and also for VCM out we have an equation. VCM out we have an equation that is VDD minus RD times ISS divided by 2. For VCM out 1.6 voltage, at least 1.6 voltage. Each resistor must sustain a voltage drop no more than 200 voltage. So let's set the maximum value for RD, that is 360 ohm, and also setting gmRD to be 5. We must choose a transistor that should be this one. GM is 5 over RD. 5 over RD. RD is 360. So we had to have a GM 5 over 360. Okay, this is ohm. Now we want to find out W over L. That's our final thing to find out. So let's write the equation for the transconductance. GM is given by 2 μnCox, W over L, ISS divided by 2, and from this one if you solve for W over L, that is 1738. So a large aspect of ratio arises from the small drop allowed across the load's resistors. And this is our final answer. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.